All right. Little relationship between sine and cosine. Little relationship. First thing I need you to do by yourself or in your groups is using my right triangle there. Can you find the ratio that's equal to sine of A? All right, sine of A. Go from angle A and find the sine using those lengths. I'm not looking for a number or degree measure. Guys, just go from angle A and find me the ratio of sine. Okay, you guys know how to find sine going into tomorrow's quiz. So find me that ratio. What's the sine of A equal to using your right triangle there? No calculator needed. Got that ratio? 19, got the ratio? Opposite side y over hypotenuse z. Nice job back there. Now I got a real challenge for you, either by yourself or in your group. Find me another ratio that would come out to be y over z. Don't do sine of A again. I want maybe a different angle, maybe a different ratio. I don't know, but I need something different than sine of A that will also equal y over z. Go ahead. I'll give you guys a little longer to think about this one or discuss it. Find another ratio that's going to be the same, going to be equal to y over z. When you do hypotenuse, adjacent, opposite, it also comes out to be y over z. Give you enough time? 26, find the ratio. Nice job, Jack. Cosine of C is also equal to y over z. Everyone agrees? So when we're in a right triangle, there's going to be a couple ratios that are always equal to each other. In your group or by yourself right now, what angle A and angle C? What do you know about angle A and angle C? I'm looking for a specific vocabulary term here. And I'll give you a hint. Angle B is already a right angle. And there's 180 degrees in every triangle. What do I know about angles A and angle C? I won't call on anybody here. This one's a tough one. Anybody think they know? Sam? Add up to 90. What do we call two angles that add up to 90? Complementary. Yes, angles A and C, they are complementary. They add to 90. All right, we're not ready for a conclusion yet. Billy, you're up first. Just give me an angle less than 90. Okay, everyone in your calculator right now. All right, in your calculator, please do the sine of 42. Everyone got that hot decimal right there in front of you? Now, right underneath, do the cosine 48. And no, I'm not a magician. You'll find this in a second. Bella, give me another angle. Less than 90. 32, everybody. Everyone in your calculator, do the cosine of 32. What do you think I'm going to ask you to type in now? Cosine again? No, I'm going to ask you to do the sine of what angle? Predict. Oh, look at you guys. Go ahead, try it out. One more just to solidify things here. Emma, you want to give me an angle less than 90? 60. Can we get off the twos? Is that okay? So 63, all right. Sine of 63, everybody. What do you think that decimal is going to be equal to? The same as cosine of 27? Is that true? What am I trying to show you here? If sine and cosine are ever going to be equal to each other, what do you got to know about the two angles? If sine and cosine are going to be set equal to each other, you should know what about the two angles? Complementary, yes. All right. So here's our conclusion. We can start with sine or cosine. It doesn't matter. I'll start with the sine. A sine of any acute angle will always be equal to what? If you have an acute angle, that'll always be equal to the what? Cosine of, I'm trying to, let's lessen the words here. How do you find that other angle? How'd you find 48, 58, 27? It's going to be 90 minus whatever the angle was. Always. If you see sine and cosine equal to each other, that tells me their angles have to add to 90, whatever they are. All right? We're all right. Okay, let's apply it. The directions may be a little sketchy here. Ready? Let me clean them up for you. Express the following as an equivalent trigonometry. Here's what I'm looking for. Rewrite cosine of 20 as a new ratio with a new angle. That's what I want right now. Cosine of 20 is equal to what? A new ratio, not cosine again, and a new angle. I don't want the decimal on your calculator. That's what I'm looking for here. The cosine of 20 should be equal to what? As a new ratio and a new angle. Thoughts? 2? Sine of 70. They're always equal if their angles add to 90. How about the sine of 37? Rewrite that as a new ratio and a new angle measure. 25? Yeah, watch your mouth there. Cosine of what? Thank you. All right, you guys are good there. Here's where I got to have you spot on now. X and x plus 20, measures of two acute angles. And I'm telling you the sine of that angle and the cosine of this angle, x plus 20, are equal. Find x. And then you guys just forget everything we just did, and then this is what I see. Oh, they're equal. X equals x plus 20, and I'll try to solve that. Oh, you're not picking up what I just showed you. Ready? If sine and cosine are going to be equal to each other, what do you know about the two angles then? If sine and cosine are equal, what do I know about those two angles? Complementary. So you wouldn't set them equal to each other. What equation could I set up, though, to find x? I could say x plus the other angle, x plus 20. They have to add to what? 90 if sine and cosine are going to be equal. Whew. Now you can find x. Get out of that habit. If you see sine and cosine equal, don't automatically set them equal. They add to 90 their angles then. All right? All right, number 4, same thing I asked for at the beginning. I got cosine of 83. Rewrite it as a different function. So rewrite it with a different ratio, and then hopefully your angle comes out to be less than 45. Okay? Hopefully your angle comes out to be less than 45. Cosine of 83 will be the same measure as 21. What do you got for me? Sine of 7. How'd you know the 7, Emma? And not any other number? There you go. And sine and cosine are only equal if their angles add to what? 90. So it had to be 7. No other number is going to add to get you 90 from 83. Change the directions on number 5 for me. Just say find x. All right, just say find x. I just want to make sure you guys have the basics of this. Just find x. Set them equal, right? X plus 15 equals 45? No, no, no. Get out of there. If sine and cosine are equal, again, ask somebody here. 12, what do I know about their angles? So I should see x plus 15 plus 45 equal to 90. Don't set them equal to each other. What? The angle does, yes, but not x. So if you saw that and then you want to do x plus 15 equals 45, you could. Yes. Okay, but x wouldn't equal 45 though. All right. That would be my worry. So x equals 30. There's no doubt in my mind you'll be able to finish the homework. But before I let you go to the homework, take a look at it, please, so you don't start getting freaked out. What's part? Like, give me a couple of the numbers here. That's part of the homework. What's in this section here? The 13 to 23 section. What did I assign? Okay, so let me look at 17 real quick. All right, just so you're not freaked. Those are not zeros on number 17. It's called theta. It's a variable. If you want to replace it with x instead, that's fine. All right, those are not zeros. It's not the sine of 0 equals cosine of 2, 0. All right, it's just sine of theta. If you want to replace it with an x, that's fine. Hey, here you go. Take a look. So number 17 is the same as sine of x equals cosine of 2x. Find the value of x. Okay, it's a variable. And what do you know about these two? They're not equal. What do? Add up to 90. Okay, so don't be freaked out. These are not zeros. They are what we call theta, which is a variable. And you also have a Regents review problem. You can get all of it done right now. Go ahead and get all of it done right now. Even take a look at the answers too. I have enough time for.